In this problem, we're given that a radioactive substance decays exponentially. A scientist begins with 140 milligrams of a radioactive substance. After 29 hours, only 70 milligrams remains. How many milligrams will remain after 53 hours? The key to this problem is to realize that they said it decays exponentially. So if I'm supposed to predict a quantity after a future time value, it'll be sufficient for me to find an exponential equation. Assuming your professor lets you find exponential equations using regression, go to your calculator, turn it on, press Stat, press Enter to edit a list. If there's any data in your List 1 and List 2, simply press Delete if you highlighted the number you want to delete. Right arrow over to delete any numbers in L2. I'm going to go back by pressing left. Now it said a scientist begins. I'm going to call L1 time and L2 quantity. So if he begins with 140 milligrams, that's times 0. So I'm going to type in 0, and then I'm going to right arrow over and type in 140 milligrams for my quantity. So it's important to keep straight that my input is time in L1 and my output is going to be quantity. I'm going to left arrow over. It also says after 29 hours, I'm going to type in 29, press Enter, then right arrow over. It says after 29 hours there's 70 milligrams left, so press 70, press Enter. Now I have the data in. It takes 2 points at minimum to find the equation of an exponential. And if I want exponential regression, that can be obtained by simply pressing Stat, right arrow, and then option number 10 can be accessed just by pressing 0. Option 10 is exponential regression. So doing that, my screen may look a little different than yours. And most calculators, if you press Enter once or twice, you get the regression equation. On my calculator, I'm going to have to go down to calculate, either by down arrowing down or just pressing Enter till I get down there and hit calculate. So it tells me that it did give me exponential regression. Y equals AB to the x. Proceeds to tell me the A value and the B value. So the A value is not surprising. That was the start value of 140 milligrams. What I didn't know in the story was what the growth factor was, in this case decay factor. And now I just need to take this equation and write it out. And if you did that, it should look something like this. Since A is 140 and B is this number 0.976, and it said exponentials y equals AB to the x, just inserting A and B into the letters there, you would get this equation, which is exponential. To help remind me what the variables are, I replaced x with t because that's time, that's my input. Remember when we typed the data in, we typed in the inputs into L1 and it was the time values. And my output is the quantity left over. Since the question said, what's the quantity after time equals 53 hours, right there, 53 hours, I'm going to plug in 53 in for my input. So notice that I rounded B to several decimal places. This is critical. In fact, most students get this problem wrong because of rounding. It says that we only need to give our answer accurate to 1 decimal place. So some students think if you just round B to 1 decimal place, that will be sufficient. But rounding B to 1 decimal place, or even 2 sometimes, will not even be close to being accurate. Because if you look at it, B is being raised to the 53rd power. So what happens if you round this, say, to 0.98, you're using that wrong or rounded number 53 times in the calculation, and every time you use it, it gets worse and worse. So let's type it in using the full accuracy of the calculator and see what we get. I'm going to go to the calculator and type in 140, left parenthesis, 0.97638. 175. Hopefully I'm going slow enough for you to duplicate this on your own calculator if you're following along. And then I'm going to raise to caret 53 and see what I get. I get that the quantity is roughly 39.4 if you round to 1 decimal place. Just to show you what would happen if you rounded B to say even 2 decimal places. So the idea is maybe you think that rounding B to 2 decimal places would guarantee accuracy to 1 decimal. Watch how bad this estimate is if I round B to the 0.98. and raise to the 53 power if I press Enter. The real answer is 39.44. I'm now getting an answer of 47.98. It's not even accurate to the tens place. You're predicting the quantity is going to be 47, and the real answer is 39. So rounding B to 2 decimal places doesn't even get you in the ballpark of the right answer. So students get frustrated on this problem when they swear they're doing everything right, but all they're really doing is not typing in enough digits. Probably if you rounded B to 4 or 5 decimal places, it would have been sufficient to get 39.4. In fact, just because I'm curious, I'm going to round B to, say, 4 decimal places, 0.976. 4, and raised to the 53rd, I'm kind of suspicious because the 53rd power is so high that it still might not give me 39.4. It did, but you'd probably round that to 39.5 now and you'd still get the problem wrong. So I would round B to several decimal places like I did in this example. Let me go back to MathAS now and see if I can get MathAS to give me credit. Actually, I can just hit show answer. And since this is in review mode, you can see that the answer MathAS is looking for is this. It only requires 1 decimal place accuracy. In my original answer, where I rounded B to like 6 or 7 decimal places, I'm getting accuracy all the way out to the 9, 39.4429. Got 4 decimal place accuracy.